Hello guys and welcome back to another episode on chemistry, and of course today we're going to continue our study on alkanols. Specifically, we're going to be looking at, so this is chemistry, and we're going to be looking at preparation of alkanols. Preparation of alkanols. All right, so how do we prepare alkanols? All right, so do not forget that this tutorial is brought to you by the OTD School JAMB CBT Practice app. It's an application that has helped millions of students gain admission into several universities and different universities. So please do not joke on the app. Before we talk about the app in a bit, let us see a question from the app. This is a 2014 question. This has to do with preparation of alkanols. Number 44, it says, the process of converting starch to ethanol, all right, is A, distillation, B, fermentation, C, oxidation, D, cracking. All right, so keep the answer, keep the thought, hold your line of thought. When we are done with the class, we'll come back to this question and many more from this application. So please do not forget to go and download your app immediately. If you have other apps in your phone, no problem. But this one is a go-to app. You must have it, all right, because it has all the past questions you need for your exam. All right, so you don't need to worry about going to buy past questions outside. Then number 2, it has lecture notes that are structured according to the JAMB syllabus. All right, so if you have that app, you do not need to go and worry about buying textbook, because some of you also read without your JAMB syllabus, and it's a big no. It's a big no. It's a big problem for you. All right, so you must read according to your JAMB syllabus. Then thirdly, it has a question search feature where you can search for questions according to topics, and all the questions that JAMB has set up from that topic will come out for you to answer, thereby building your confidence. Then lastly, of course, we also have a bomb feature called what? The UTME mock challenge. It's a mock challenge that will conduct for all students that are writing JAMB for this particular year. Every Saturday, you must participate in that mock. All right, you get used to what? Past questions, get used to JAMB likely exam question, see your score released every Saturday, thereby tracking your progress and building your confidence towards the main exam. Activation for this app is just a little token. Ensure that you pay the sacrifice, activate your app, and join us. All right, so do not forget to like the video, because liking the video will make other students easily find this video. All right, you know what made a pass, so please like the video. Then do not forget to subscribe to this channel. This channel subscription is free. All right, so subscription is just to send notification to your phone that we have released a new video. That way you can be able to keep track with us. All right, do not forget to share this video to your class group, to your friends, to your loved ones, even your enemies waiting no good. Share it to them. Let's go to preparation of alkanols. So alkanols can be prepared by a number of methods, all right? So, or alcohols rather, that is a trivial name for alkanols, can be prepared by a number of methods, all right? And one of the first methods we're going to be looking at is the hydrolysis, number 1. Hydrolysis of haloalkanes. Okay, so hydrolysis of haloalkanes is one of the first methods we're going to be looking at under the preparation of alkanols. So first of all, I think the first thing that comes to your mind is, what is an haloalkane? Where that one for come again? All right, so it's very easy. There are only 2 words here. That's an halogen and there's an alkane. Okay, this means that an halogenalkane is an alkane in which one of the hydrogen atom has been replaced by an halogen. Get it now? So we have an alkane. Let's say, for example, like ethane. All right, this is ethane. 1, 2, 3, 4, 5, 6. This is our ethane. But one of the hydrogen atom has been replaced by an halogen like chlorine or bromine or iodine and the likes. All right, so this now becomes an halogenalkane, an alkane that has halogen in it. Okay, that has halogen in its structure, or an alkane that carry halogen for head, waiting no good. So that is an halogenalkane. You get it now? So that makes it very easy. So hydrolysis of halogenalkanes gives us the corresponding alcohol with the same number of carbon atom. All right, so then if we carry out hydrolysis, all right, we carry out hydrolysis on on an alkene that has one carbon atom, we're going to have what? An alcohol that has one carbon atom. If we carry out hydrolysis of halogenation, hydrolysis of halogenalkanes on an halogenalkane that has two carbons, all right, the alcohol that will be produced will also have two carbon atoms. All right, so let us see examples. So the reagent that we use, okay, for this reaction, the reagent, look at what the reagents. The reagent that we use to carry out this reaction is what? Aqueous KOH or NaOH. Okay, we use what? Aqueous KOH or NaOH, then plus what now? Plus heat. Okay, so when we use what? Aqueous KOH or NaOH, all right, on an halogenalkane, what it gives to us is the corresponding alcohol, all right, having the same number of carbon atom as that of halogenalkane. All right, so let us see an example. All right, so if we have an halogenalkane, for example, like methyl chloride, CH3Cl, all right, when we react this with what? Let's say NaOH, all right, of course, in the presence of what now? Heat, all right, in the presence of heat, like we say, we use what? Aqueous NaOH or KOH, okay, or KOH, and then plus what? Heat. These are our tools. This is what we use to carry out this reaction. Okay, so this is our halogenalkane. This is what? Chloromethane. These are what? Our sodium hydroxide. All right, then we apply it to it. Then it gives us what now? It gives us what? Methanol, CH3OH. Okay, it gives us what? Methanol. All right, so from here, look at it. Look at what happens here. The CH3H, then what? Now have what? Cl here. Okay, this is our what? Our chloromethane. All right, so the alcohol that will be formed, all right, the OH will replace what? This halogen. Okay, the OH will replace this halogen in the product side. Okay, so it is where this halogen is. That is where the OH will appear. Okay, so that if we now have, let's say for example, 5 carbon atom, 1, 2, 3, 4, 5, for example, and then the halogen is now here. That means that once you are forming the alcohol, the position of the OH group will still be where that halogen is. You get? I'm just trying to bring out that point. So you have to take note of that. So this is what our methanol. Then they see another product that will be left. NaCl will be left. Then plus what now? NaCl. All right. This is our methanol. And then this is our now? Sodium chloride. All right, so this is what happens when an halogenalkane, okay, when hydrolysis happens on an halogenalkane. All right, so hydrolysis is the process of producing or preparing an alkanol, all right, from a halogenalkane. All right, take note of that. That is hydrolysis. All right, so now let's just say we have, for example, a carbon atom, okay, an halogenalkane having like 3 carbon atoms. Let's say, for example, like C. Now this is propanol. This is propane. Sorry. Okay. Let's say here is what is Cl. Here is H. I hope you get what I'm doing. All right, this is what? Propane. But what? It has been, one of the hydrogen atom has been replaced by what? By chlorine here. So now let's say we now react it to 2, or let's say we use KOH this time, which is potassium hydroxide. Then also the same condition in the presence of heat. All right, what are we going to have? I'm going to have what? I'm going to have what? An alkanol. All right, that has what? 3 carbon atoms. So we are going to have C. Okay, here now instead of this Cl, now I'm going to have what? OH. All right, we can now complete our structure. H. Sorry if you're not seeing my small h. Okay, but that is that for that. Then we'll now have what? Another product left. What's our product that is left? Let's say, in fact, let us say yes, even bromine, so Br. Okay, so we're now going to have what now? Our product that will be left will be what now? Plus what? KBr. Simple as ABC. All right, so please, that's how we prepare alkanols, okay, from what? From hydrolysis of what? Of halogenalkanes. Take note of what of that. So the conversion of an halogenalkane, all right, to an alcohol is what we call what? Hydrolysis. Take note of that. Very important. So let us now see another method that we can use in preparing what? An alkanol, all right? Or for preparing our alcohols. And this one is called hydration of alkenes. Hydration of alkenes. Hydration of alkenes. That's the second method we use to what? To prepare alkanols. Hydration of alkenes. Then number 2. Hydration of what? Of alkenes. When we're talking about alkenes, okay, one of the methods that we use in preparing alkenes was dehydration of alkanols. If you remember very well, dehydration of what? Of alkanols or alcohols, okay? This was one of the methods that we used in preparing what? Alkenes. Remember very well that time. But now, hydration of what? Of alkenes means that we have an alkene, all right? Then we are adding water. Hydration is addition of water. So hydration of alkenes is a method of preparing what? Alcohols. Why? If you want to now prepare the alkene, what do? You dehydrate the what? The alcohol. Okay? When you dehydrate, it means you are removing the water. Okay, so you understand what I'm saying? So hydration of what? Of alkenes will produce an alcohol. The dehydration of an alcohol or an alkanol give us what? An alkene. All right, so please take note of all that. All right, so now conversion of an alkene to an alcohol is what we call is called what? Hydration. All right, and the main reagent that we use here is what? Is water. The main reagent is what? Our H2O, which is what? Our water. Okay, and what's more also is that we also use what? An acid catalyst. We use an acid catalyst. You must take note of that. The catalyst could be concentrated H2SO4 or phosphoric acid. That is what? H3PO4. Okay, so we use what? Either what? Concentrated H2SO4 or use what? Phosphoric what? Acid. All right, then likewise, this reaction happens also in the presence of what? Of a high temperature. So we use high temperature of about 80 degrees Celsius. Then likewise, we also use what? A high pressure of 25 to what? 30 degree, 25 to 30 atm atmospheric what? Pressure. Okay, so take note of the reaction conditions. All right, so the main reagent is our water, H2O. Then we use an acid catalyst, either concentrated H2SO4 or phosphoric acid. Then we use what? High temperature, which is what? Around 80 degrees Celsius, and a high pressure of 25 to 30 atmospheric pressure. So doing this now, we'll now get our corresponding what? Alcohol. All right, so let us go, let us see. Please take note of all that. Write it somewhere tight so you can always what? Get your hands what? Around it. And please do not forget to like the video. Please like, subscribe to this channel. Subscribe. I mean, we know they try. Subscribe. All right, subscribe and what? Keep sharing. Share. If I've subscribed before, thank you so very much for doing that. So let us see hydration of alkene. Let's say, for example, we use what? Ethene. Ethene is C2H4. Okay, so when what? Carry out hydration means that we are adding water to it. All right, so plus what now? Is it water is what? H2O. All right, when we add water, the condition of the reaction, of course, is concentrated conc H2SO4. All right, we use what? 80 degrees Celsius, 25 to 30 atm. These are the reaction conditions. Okay, so this is ethene. Put it here. Ethene, and then this is what? Our water. All right, so what that one give us? The product of this reaction will be what now? Our alcohol. All right, we have added water rather to what? To an alkene. So right now we're going to form what? An alcohol having the same number of carbon atoms. Okay, having the same number of carbon atoms, all right, as the what? Alkene that was what? Hydrated. So what I'm going to have is what now? C2H5OH, which is what now? Ethanol. Okay, so this will give us what? Our ethanol having 2 carbon atoms, just like what? Like the alkene that was what? That was hydrated. It's as simple as ABC. All right, so now that is that for that. Let's say we now have, for example, butene. Okay, let's say we have butene. Butene will have a 4 carbon atom. That will be C4H8. All right, plus what now? H2O again. This is butene. Some of you will call it a but1-ene. All right, it means that this butene now. This is butene 1, 2, 3. Okay, 3, 4. Okay, then here will be 1. There will be 1. All right, 1, 1, 1, 1, 1, 1, 1. This is our butene. You can call it but1-ene. All right, but if you see butene, it means that what? That of course that the double bond is on the first carbon. That's why we do not put what? The 1. All right, if you see butene, if you see but1-ene, okay, then maybe but1-ene is telling you that the first, that the double bond is what is on the first carbon atom. Butene is also telling you that that the double bond is also on the first carbon. That's what it means. That's why sometimes we do not put but1-ene. All right, but if I have but1-ene, okay, or butene, as you may have it, you can now have what carry out hydration by adding water. Then the same reaction condition, of course, conc. All right, so we can use what? H3PO4 now. Okay, that's phosphoric acid, 80 degrees Celsius, 25 to 30 atm. All right, then of course, what I'm going to have? I'm going to have an alkanol having 4 carbon atoms. That is C. All right, I'm going to have what? An alkanol having 4 carbon atoms. C, C. All right, C, C. All right, then I'm going to have what? Your OH. You can now continue. All right, this is our butanol. All right, this is called our what? Butanol. Okay, or you can call it butan1 also. So that is butanol. All right, so that's what it will give to us. Okay, so please understand what hydration of alkenes, and the reverse is what? Is dehydration of alcohols. Okay, dehydration of alcohols will give us alkenes. Hydration of alkenes will give us alcohols. Very simple and straight to the point. All right, so hydration, of course, is the process of what? Of producing or preparing what? An alkanol from an alkane. So let us see the third method, the third and final method we use in preparing alkanols. All right, and that one is called fermentation. Fermentation is by far the very most popular method. Okay, by fermentation. I think even from when you were small, you might be hearing about, you must have heard about fermentation, all right, from your very little age. So fermentation is very, 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 very easy, and so it is faster. Okay, so let us see number 3. By fermentation. Okay, alcohols are prepared, okay, by the fermentation of sugar or starches in the presence of yeast. Okay, alcohols, they are prepared. We say alkanols or alcohols are prepared by the fermentation. Okay, they are prepared by the fermentation of sugars or what? Starches. Okay, in the presence of yeast. Okay, in the presence of what? Of yeast. Okay, so fermentation is the process whereby alkanols are prepared. All right. Okay, by the breaking down of what? Of sugar or starches. All right, so you break down sugar, or you can just say it is the breakdown. Fermentation is the breakdown. It's the breakdown of what? Of sugars or starches. Take note of what? Of that. All right, so this happens in the presence of what? Of an enzyme I will call Z-mase. All right, Z-mase. Okay, it's the enzyme. Okay, that this reaction what uses. Please take note of all this. All right, so fermentation, alkanols can prepare by the fermentation of sugars or starches in the presence of yeast. It's the breakdown of sugars or what? Starches. So let us see an example. Let's say we have what? A sugar. Okay, like glucose, C6H12O6. Okay, that's what our glucose, C6H12O6. All right, if we put our reactive to what? Our enzyme. Let's say we use our Z-mase. All right, as our enzyme, then of course what it will give to us is ethanol. Right, this will give us our ethanol. Okay, sorry, C2, which is C2H5OH. Okay, to give us our ethanol, and then of course, obviously, not only our ethanol that will be given, because if you check very well, our reaction will not be balanced. So it also gives us what? CO2 as what as product. Okay, we can balance this reaction like this. All right, so this is what fermentation. This is fermentation, whereby what? sugars or starches break down in the presence of what? Of yeast, okay, to give us what? Our alcohol, right? So take note of this. This fermentation process usually gives us about 10% by volume of what? Of alcohol, all right? It gives us about 10% by volume, all right? But if you want to get higher concentration of what? Of alcohol, what you do is that you carry out fractional distillation. You carry out fractional distillation. And another important thing to note here is that alcohol that is 95% pure, alcohol that is 95% pure, okay, is called rectified spirit. Rectified spirit. Alcohol that is 95% sure is called what? Rectified spirit. While alcohol that is 99.5% pure, okay, percent pure, this one is called absolute alcohol. All right, please take note of that. All right, so alcohol that is what? 95% pure is called rectified spirit, while alcohol that is 99.5% pure is what? Called what? Absolute alcohol. And please take note that what? There are reaction conditions for this fermentation, okay? This reaction will be, or this fermentation process must take place in the absence of oxygen, okay? In the absence of oxygen. What we mean is that it should be what? It should be airtight. It should be airtight, okay? It should be airtight in the absence of what? Of oxygen. The temperature should be around 25 to 30 degrees Celsius also. All right, so please, you must take note of what? Of that. So it is fermentation is by far the easiest, it's by far the fastest method of what? Of making what? Our alcohol, like what? Like ethanol, where we break down starch or what? Or sugar. All right, so these are the methods we're going to look at for preparation of what? Of alkanols. In the next class, we are going to be looking at the reactions that alkanols would undergo. But before that, let us see a question. Let us see the answers to our questions from the O3 School JAMB CBT app. So please go to your app right now. Go to 2014 number 44. As you can see, it being displayed on the screen. The process of converting starch to ethanol, obviously, is fermentation. I know go waste time there. Let's go. 2001 number 35. You can see it's a very, very common question. Fermentation is the A, breaking down of carbohydrate to glucose. No. B, conversion of sugar to alcohol in the presence of yeast, which is very, very correct there. All right, so our option B will be correct. Now, 2002, number 38, the same thing again came out again, another format. Ethanol can be produced by fermentation of starch. All right, so please go to the application, download it, activate it for your own good. All right, and pay for your own good. All right, do not be stingy to yourself. Your success is very important. In fact, you do not want to write JAMB twice. Pass your JAMB at once. This app guarantees that. My name remains Master T, the Grand Commander of this great army. In the next episode, we are going to be looking at the reactions of alkanols. See you there.